Thank you. Thank you. Yeah. Thank you so much for organizing the event. And it's really, as many speakers said, it's a great honor. So I want to give you a slogan for this, for the talk, and so that you can put that in mind. And in some of the talks that we have listened to, at some point it was the idea of, okay, what kind of was the outline, a piece of work in classical logic was advocating in classical outlook. And so the slogan is, yes, not enough. So the talk today is going to be about some theories that are hopefully inspired, and we'll see a precise sense in which they are inspired by the work in the outline, but also they take the classical step, the classical outlook that Kripke was taking in the paper, and it realizes fully, let's say, or in a more substantial way. Let's see. Okay, so let's start with some notes from the outline. Many of these you have seen already, but so I will make some claims in this introduction, and hopefully they will be backed by quotes from the paper. So the first is that the outline is a philosophical semanticist, or just a philosopher's reflection on the semantic properties of a language with a self-applicable truth predicate. Okay, of course, I mean, this is the reflective element is clear in this passage. So we're told that models presented in the paper are plausible models of natural language at a stage before we reflect on the generation process associated with the concept of truth. So when we theorize about truth, we are already at this reflection state. So the language is a piece of the language of the self-applicable truth predicates is our object of study, and we are there when we reason, and of course, yeah, and then one can make this even more perspective by saying that the perspective is, because this is like the semantic perspective, so we are constructing a class of models, and we're constructing a class of models in a set theoretic background, which is implicitly supposed to be classical. Okay, but what are we then doing? Second big claim. Well, we then, from this classical perspective, from this reflective perspective, we're analyzing sentences, and we are able to extract clear truth conditions and patterns with which to analyze the language of truth. And we're fully capable of doing so, including unraveling the structure of truth ascriptions all the way until we reach something that doesn't contain truth for a specific class of sentences, well, in this case, the determinate ones. And so here there's this distinction that is in the paper on page 699 is about, so we have these sentences around. Some of them we reason with, some of them are, well, we have this language of truth, but many sentences are well formed, and not for all of them we're able to fully analyze truth conditions and perform this reflective step in a full way. Only for some of them. And so, but well-formedness is everywhere. But having a determinate truth condition, or in this jargon expressing propositional, though this is risky, of course, I mean, saying that, because you need to be able to then refer to the specific literature. But at least, I mean, there is a distinction there. Well-formedness, actually, in the paper, Kripke also talks about meaningfulness versus expressing a proposition, although maybe it's better just to say, well, being syntactically well-formed and having a completely well-specified form versus having determinate truth conditions and expressing the proposition. And of course, I mean, in one of the perhaps in the most widespread way of understanding these truth conditions, this will be the strong feeling points. And this theme will be kept fixed in what I'm going to say later. Okay, now we depart a little bit from the outline. So if you recall Michael's talk, I mean, he was talking about basically dividing up the classical options in two. So a semantic perspective and a more axiomatic perspective. I would love if these two perspectives were one and the same, but informing each other using modified Kant's motto. So it's axiomatic theories without semantic theories are empty, and semantic theories without axiomatic theories are blind. so it would be good to keep them together. But with the semantic theories, of course, there is such a heavy machinery involved sometimes, as we've seen, that one loses track exactly of what are precisely the principles of truth one employs and that are in focus. So that's why an axiomatic theory, so having principles and laws just in mind, is also helpful. And it's not always, but of course, I mean, just having laws and just throwing consistent sets of laws of truth together without a picture, a story, or they would say a semantics, it's also not nice. So having them together, and there is a precise sense in which this could work. Right? So, okay, so let me just tell you the precise sense. So a precise sense is what this notion of n-categoricity, that in a sense, I think connects the classes of models, of standard models presented in the paper, and some axiomatic theories. Now, here I am taking the external perspective, the classical outlook, looking at the fixed point structures. So I'm looking at the external theory, as John Burgess referred to as that. So this is the KF theory that has been mentioned, and it's the simplest and most natural axiomatic formulation of Kripke's set theoretic definition of fixed point models, external theory. And so I'm not advocating KF here, but I'm just saying that if you are looking at an example, this kind of bridge between models, intuitions, and theories, these kinds of properties is the things that you're looking for, these kind of relationships. And so that the omega models, so the fixed points, are precisely, or the theory, are precisely the fixed points. And so that's what you're looking for. And this is an important fact that you would, at least a necessary condition for something to be a nice mixture of semantic intuition and axiomatic fiction. Okay, so going backwards, I wanted to say that well, let's say, okay, so now we have, okay, I claim that that we're taking this classical outlook faithful to the outline. In this classical outlook at looking at a fixed point structure, you have well-formed sentences, but you also have some subclass of sentences that are determinate for which you can do semantics work. It's like we are the semanticists, we are looking at the language, we do semantic work, but now we are formalizing it using an axiomatic theory. So we also have a truth predicate, what Kripke referred to as a standard mathematical result in set theory. Now we're formalizing this work. So we also have the truth predicate that it was defined using conventional mathematics. Now it's also, like it happens with the KF theory, it's our primitive truth predicate. And of course, this creates a little bit of confusion and puzzling claims, like the one that came up often in discussion, right? Oh, what happens to things like the liar and the liar is not true? They're saying the liar and the liar is not true. Well, there are several things to say about that. I mean, first of all, liar as also the non-classical logicians will know very well, or at least non-classical people that would look at fixed points from non-classical internal perspective will know that the liar is not like the case of Trump is a corrupt politician, right? Trump is a corrupt politician is determinate. Right? So we don't have to say anything. We don't have any of these ill-behaved sentences of that kind. It will be the liar that behaves in that way. And then we can say something about the lie. But liar and the liar is not true. From the classical perspective, is equivalent to say that the T-schema fails the liar. It's just the same thing, right? It's just not the condition. So, and not the other condition. So from that perspective, not that bad. Of course, you have to buy a distinction between inside your language, there's this perspective. So there are things that you need to buy into, but it's not immediately hopeless. Okay. So, okay, why did I say that I wanted to take this classicality a step further? Because, and maybe this is the part of the talk that is a bit too optimistic, but you will see that from the work, that the formal work, this picture will come out. So I would like to push this classicality a bit further. Okay, so we already in KF, we need to buy, on the external theory, we need to buy a distinction between the classical reflection, semanticist external outlook, and what we do internally when we do this actual semantic work of analyzing sentences. Now, we have an external truth predicate in classical. What are the things that we want to do in general when we do conventional mathematics and we replace a defined truth predicate with a primitive one? What do we want to do? We want to, well, we want to prove laws, classical laws, and that will get even in KF. So, for instance, I mean, of course, in the outline you have claims of the form. The meta-language, which is now our formalized external theory, does not contain any gaps. A sentence either does not have a truth value in a given fixed point. But what you also want to do, you're now in a classical environment in which you have an external truth predicate doing your work. And you also want to just be faithful to one of the things the truth predicate is good for. So generalizing. And you're endorsing classical logic because you are having this reflective attitude. Why not being able to prove that classical logic with T in general is true? You already made a distinction. You need to, if you buy into the KF world, you need to make a distinction between an external, a class of well-formed sentences and a subclass. And now, if you have this distinction, then avail yourself with all the nice tools that an external truth predicate can have. And how do you get this generalizing feature? Well, usually you get them. This is a byproduct of having, hence the terrible title I gave, that is having full compositionality or truth in fully quantified form will give you generalizing power. And so you will be able to just reason in general, in classical logic, externally about sentences, even without knowing what these sentences are. What in terms of blind deduction. So for instance, an example of this blind deduction, everything Gerhardt says about path elimination is true. Maybe David asserted the negation of some of Gerhardt's claim, therefore something David asserted is not true. Here implicitly I'm using commutation of negation with truth, but with sentences that I know nothing about, not exhibiting. It's purely at the general form, purely quantified. For instance, and you want to do that to fulfill the generalizing role. So I'm just, now I will get into a bit more details, but I hope you get a sense of what I'm trying to say. So you start with outline, you have a KF theory, it's an external theory. You need to buy into some asymmetry, what you can do externally, what you can do internally. The reason for that is that you want to keep classical logic and embrace classical logic fully so that you can fulfill the generalizing role as well. if you do these two things, do you get nice theories with nice models and theories that axiomatize those models in the sense of not n categoricity? Can you do that? That's the main question. Okay. Right. So implicitly, I referred to some principles of full compositional clauses in quantified form for any sentence in the language, and good truth conditions for determinate. It turns out that a theory like that, well, just a set of principles like that, not a class of models like that coming from the outline, was recently presented or studied by Volker, Halbach, and Kentaro Fujimoto, and they were just trying to combine these two worlds, but just from the proof theoretic perspective. So they presented a theory. Sorry about that, but I will try to highlight it. So these are just the compositional axioms we mentioned. Commutation. Oh, sorry, this should be clear. Sorry, biconditional, of course. Right? Very important. It's a biconditional. Biconditional, just commutation, just a task close, but generalized to contain truth and this new predicate of determinacy. So then we have still here we are. These are compositional clauses. These are basically what are the disquotational properties of truth? So truth is disquotational for atomic for sentences that do not contain truth. The truth predicate is disquotational for the determinacy predicate as well. And you've got the internal, you've got the T-schema as long as you have a determinate. And then we have clauses for the determinacy predicate, which are just the KF clause. So if you are thinking about when is a sentence determinate in the sense of strong cleaning, to think about that, it's either true or false. Right? Either it has a classical value, so that it has a classical value, right? Either classically true or either classically false. And this, if you just think of this D as that, either true or false, you will get these principles in the Kripke world. So atomic sentence without truth or determinacy are determinate because the known truth and non-determinate is always determinate. Then if you know that something is determinate, also a truth description is going to be determinate, and vice versa, and so for determinacy. And these are the determinacy conditions for strong clean. Right? So imagine this is saying that phi is either classically true or classically false, and therefore the non-negative version of phi is. Or when is a conjunction determinate? Well, either both things are, or one is and it's false. Well, the conjunction, so you know that. And the universal quantifier is just a generalization of that. So either they are both determinate, or one of the two is determinate and false, or the other is determinate and false. Just a strong, clean truth condition. Now, okay, so they have this theory, but there's no connection to the outline. I am making it. So the surprising bit that I want to tell you then is that in fact you can do the same theory. This is the content of this paper. You do the same theory with a thoroughly Kripkean outlook, including an n-categoricity result. So connecting models and axiomatic theories. That's what I'm going to do. Okay, so instead, I mean, this theory does not have a Kripkean model, has an omega model that now I will describe because I want to tell you something about it. That is following in the following way. So here, if you think about the determinants, you just go and try to go from simple to complex. You will see that these so the truth predicate, of course, is not positive here, right? Because it has the if and only if I only could change that, but the D is positive. So what they say is that, okay, here's an operator that uses the clauses, the ones that we talked about determinacy, going up into determinacy. The operator that you get from just putting these clauses together. This is this script T. Then you say, okay, basically, with the help of determinacy, you build up a hierarchy in which determinacy is what you get when you iterate this operator. And truth tags along. And importantly, at limit stages for truth, you take the intersection. Right? So you don't take everything that you get the truth, but you get the things that both determinacy and truth. And now, of course, the omega-1ck, in fact, this is a simultaneous inductive definition. So we're working over the standard model, so you get an omega-1ck closing ordinal. Anyway, so now the crucial bit, and this is what I will refer to as a classical closure. That when I said, let's take Kripke's theory and add a bit more classicality. It's not a Kripke's theory, of course, but that's what we'll do. But this is the step that we'll come back later. So you get a model, you get something, and then you just classically close one more step. Right? And you take what you got, and you take the classical, classical truths that are in this structure, and you take that as the extension. And that is, turns out it's going to be a model of these principles. Right? So in this final step, you get the compositionality, and in the previous steps, you get the determinacy. Okay, now I want to tell you why this is not a Kripkean theory as it is presented here. Well, it is if you just look at the axioms, but if you just look at determinacy, predicate, and the model, this is not a Kripkean theory. I'm going to skip the proof theoretic fact, but I just wanted to mention it. So, unsurprisingly, because we just described it this way, so you take a Kripke fixed point construction, or, well, you take a fixed point construction that closes off some CK with these features, like strong cleaning features, and then you add one layer, one classical closure on top. So unsurprisingly, the theory is going to be as strong as something like a KF theory, plus one Taskian truth predicate on top. So, and in proof theoretic terms, this is you get, well, one little epsilon more by doing this Taskian step. But that's not really relevant. Anyway, so they analyze this. Okay, now why I'm claiming again and again this is not really a Kripke theory, because it gives you a lot of freedom for the omega models, for the standard models, to play around with this classical closure. So for instance, if you take the truth set that we had before, so the one, you remember the two hierarchies, determinacy and truth, and you take the intersection. So if you take that set and you just add a random sentence, ideally, think about the liar sentence. You put it in there, and you just now do the classical closure of this, just to get a model of the theory. Now, this has these devastating consequences that so you want now, oh, sorry, I need to be close to the microphone. I speak very loud. So look at how I described the construction, right? Ideally, in a Kripkean theory, what determinacy should be, it should look into the classical layer and then be true or false. But this shows that this definition doesn't work because this is not. So there's no categoricity available. There are models that are not Kripkean determinacy. So
Carlo, could you just
Yeah,
tell us
yeah,
what
sorry.
T0 is? I'm not familiar with the notation. In the axioms.
Oh, sorry, no, this is this one, you mean?
Yes, yeah.
No, this is just like if this is the code of a sentence, this is just the evaluation function that unravels it. Right? So it's like, oh gosh. So it's like saying take true, 0 equals 0, something like that. And now this 0 equals 0 is embedded in a lots of names, right? So this just undoes one level of naming. So it will just give, so this will be true code of T code of 0 equals 0. But then you have lots of names, right? So if you want to quantify directly over this term here, you now need a way of referring to this, which is embedded inside, and just undo one. Instead of saying name, so this is the function that the inverse of name of. So if you have a x and you have name of x as a function, okay, this does the opposite. Okay. So that instead of quantifying over x and having name of, you do the opposite. You quantify over something that is a name and you undo the name. Okay. So this is just so, but it's really nothing. It's really you can replace that with sentences, and I think it will be slightly relevant. Okay, so this is what I'm just saying is that yeah. So n-categoricity, remember, so n-categoricity says omega models for n-categoricity of KF or Kripkean theory, the omega models of KF are precisely the fixed points. In this case, we would like to say that the omega models of this will give you a D that is Kripke determinate in the sense of a fixed point, and it fails. Right? So in some cases will obtain, but it's not fixed, not guaranteed. So this idea of having a tight connection between a semantic theory and axiomatic theory is not holding. Even though, prima facie, I mean, if you believe that story, but in general, I mean, these principles seem okay as principles. So that's why you need, I think, also this bit. Okay. So, but then there's a question, right? So is D necessary, and is there a Kripkean theory in the sense of having the same omega models that satisfies the same principles that are okay from the perspective that we have presented? Yeah, I mean, it turns out this is quite simple. We just do the move that we did before, but now we really start with a Kripkean world. So take a consistent fixed point, an arbitrary consistent fixed point, and it could be dualized to glottic fixed points without them. So then you take the classical closure of that. Right? So now this is basically the things that are true in the closed-off model. And now, but now you don't stop there. You take this as a set of codes that is going to be the extension zero. But now you don't need the determinacy predicate as primitive anymore. Right? Now this is Kripkean determinacy. So D is not a primitive anymore. You don't have this complex language. You're in the language of the outline, and you just define it that being Kripkean determinacy. So classical, Kripkean. So if you remove this first T, this is like Kripkean determinacy. Actually, there's being true or false. Classically true or false. And this, and here you just look at from one more layer. Okay. Now, if you just write down the same principles, but now with this contextual definition in mind. Yeah.
Can you say again the thing about classical Kripkean?
No, I mean, this is intuitive, right? So this is just one truth predicate. Okay. But it's like in the KF world that if you're outside,
yeah,
the negation is complementation, and internally the negation is falsity.
Okay.
Now you just boost it up. I would say you have
okay.
This, yeah.
But you have one truth.
One truth predicate, yes. But to do that, here you are in the, when you interpret it, here you're using the closure. Once you start getting in here, you are in the Kripkean world. So one truth predicate. Okay, and then the proposition is that this model satisfies all the principles of the Fujimoto Halbach theory. I skipped the proof, which is really simple. So I started at 2. Okay. So I want to skip the proof theory as well, but well, now you want to say, okay, did you lose anything proof theoretically by doing that? I mean, just no, because one theory can be interpreted in the other. So this theory leaves open many options, but it is compatible with a Kripkean understanding. So when you do this kind of interpretation and going from one theory to the other, you say, well, in models of this, I can find a way of understanding this. And then you can, right? Because you're not going the other way around. But so, yeah. So, and later on, we'll see that also the other direction holds, right? That this theory, just like the other one, can be interpreted in a KF plus consistency plus one task in truth, and this will they have already established that it's the same as this CD, but they are not crucial observations here. Okay, what is more important, because this is what I promised, is that to convince ourselves that there is this bridge between semantics and proof theory. And so, so if you're familiar with the Kripkean theory, sometimes you have to distinguish between the external theory, the internal logic or theories, and people. So that was the topic of our discussion as well. I mean, what is the exact principles that govern the reasoning inside a truth predicate? So here, of course, there's another distinctive set of sentences, which is let's say the deep theory. So it's external, internal, and deep. And the deep theory gives rise to a consistent fixed point, and it's governed by strong cleaning logic. So now, if you take this deep theory and then you take the closure of this deep theory taken as an extension, then you will get something that satisfies the theory as well, and vice versa. You need to know if some set of sentences satisfies can play the role of an extension, then we will know that it is the classical closure of a deep theory, which is a consistent fixed point, right, by the previous. So this is the bridge that I was promising. This is a form and categoricity. So the omega models of the theory are precisely the classical closures of Kripke fixed points. Okay. Now there is a question that I'm not sure whether it's, let's say that it is a formal question. You want to know, okay, so now you've written these principles for determinacy, you've written these principles for truth. I mean, somehow they were devised for another purpose, but they're good enough. I think I would prefer that formulation of the theory. So if you just look at this theory that you have defined, but just as a theory of truth, how would it look like? So not just going with axiomatizing determinacy via the contextual definition, but how would it look like as a theory of truth? Then, so we already know that because of this limitative results that I presented at the beginning, some of the principles that are intuitively plausible for a Kripkean deep theory, like for instance, these are strong clean clauses that hold within two layers, right? They are not provable in the Fujimoto and Halbach theory. So, but maybe now this is a Kripkean theory, so maybe there is a formulation, a reaxiomatization of the theory that is just like compositionality, full classical compositionality, and Kripkean truth conditions under two layers. Anyway, but there it is, right? So this theory they presented, CD plus P, sorry for the label, but the theory that I just presented as shown to be n-categorical is an identical theory to this one that has classical compositionality, full compositionality for everything, including course. It has strong Kleene or KF axioms under one layer of T. So just if you remove one T here, it's just KF. And of course, yeah, here we are in the consistent world, but we can dualize it, and so we are adding some form of consistency, right? Some form of T out, right? So for internally. Okay. For any consistent fixed point, again, the classical closure of that consistent fixed point is a model of this theory. We can prove internal consistency, and we can prove that, of course, the theory is a sub-theory, but of course, I told you more. I want to go here. So these are really just the same theory. And verifying this is really just a matter of mostly propositional reasoning and truth theory. But the thing that I promised before, this theory is also mutually interpretable, means that it's a particularly nice version proof theoretic reduction in which you keep the vocabulary of the base theory preserved. Right? You just translate what is. So if you divide up the language into grounded or syntactic language and truth theoretical semantic resources, this kind of interpretation just keeps the base language fixed, right? Behaves like identity there. And the key detail here is that it's really interpreting the Kripkean theory plus KF in this CKF theory. And so you need to distinguish between an internal translation, which just iterates itself using some recursion theorem. This is just completely straightforward. But an external one that it just does nothing to the Tarskian truth predicate, just replace one, but makes sure that when you hit something that is an internal, there's a KF truth predicate, just adds another layer just to be safe that you're getting to the right level. Otherwise, you're in trouble. And again, this is the same consistency strength as taking one Tarskian theory on top of KF. Okay. One thing that I said as well is that we focused on consistent fixed points, but to what extent this can be generalized. So again, another slogan here. So what happens with the Fujimoto and Halbach set of principles is that they are very underdetermined. So as we have seen, there could be Kripkean models and there could be non-Kripkean models, but also there could be consistent and there could be inconsistent models. Well, better. Gappy truth predicate models and glotty truth predicate models. In this theory, given the definition of D as true or false, we move directly into the consistent world. So you make a decision there. But if you decided to define D in another way, say a D means that is either true or false, and it's not the case, both, you are in the complete world. And similarly, an analog of the theory that is not now consistent can be defined. So you do the usual dualization technique that you do going from K3 to LP, but you do them internally. You do that internally inside two layers. Okay, we wrap up. I mean, we are up to lunch. I don't want to put you to sleep anymore. So then I did. So KF, or fractional translated dt. Let's compare what we had and connect to the introduction. KF for dt, which is essentially KF for the modifier within the internal logic. You can see them as a formalization of the some of the semanticist work carrying out fixed point construction from a classical perspective, right? But you're formalizing it instead of defining a truth value, you take it as primitive, and you need to figure out what is how the internal and external logic of the truth predicate connect to each other when you switch basically from your meta-theoretic and logical work that you do with the truth predicate, this generalizing role, but from there you go to doing semantic work and unraveling truth conditions. There are these two aspects that can or may or may not be kept together, but they're there if you take these theories as face value. So I would claim that maybe they're not full. I mean, if you still want to be faithful to this picture, which still has some idiosyncrasies to internal and external, why not fully embracing full compositionality on top? You can do that, and you remain faithful to the some of the outline, at least to the fixed point internal construction. And so, as a formalization of this, well, CKF seems better. You have both the semantic function of providing specifiable circumstances under which a sentence has determinate truth conditions. So when in the good case, you're able to unravel the semantic structure of the sentence until you reach sentences that are not contain the semantic free, they must contain truth. And when not, you can't. We can make this more perspicuous if you just to see how the semantic role there. So you define a semantic T just by defining TTX, and then strong training compositionality is and full iteration principles for this T set, are there. This fallout of the theory, especially if you look at the second formulation of the theory, right? So that's why I presented it, because there you can actually see that it's just there as a basic principles of it. And the N categoricity tells you that, there's not more. These are precisely the law of the internal form. And then there is this other aspect that is of truth, that is this generalizing form. Okay. And besides having pointwise every single classical logical truth internal, the truth predicate, you can actually prove a reflection principle, right? That all the theorems of the base theory, including truth, are true. Remember the motto, a sentence either does or does not have a truth value in a given fixed point. So this is a truth. And it's not only, it is a quantified truth, and it's true in the sense of the theory as well. Now, comparing it back to let's say, just the pure axiomatic collection of principles that are inspired by, that I started with, namely Fujimoto and Halbach's theory. This theory, or this cluster of theories, is Kripkean, and this puts in continuity the theory with a long-standing tradition, including, of course, Kripke, in defining determinacy as having a classical truth value, but also Pfefferman and Halbach, the Leon has talked about, that defines being significant precisely in terms of being true or false. So all these notions live inside the theory. They're there. And well, that's a bit of an advertisement, but seeing artificiality of TTX or true-false S can be resolved when sees as Kripkean determinist from a thoroughly classical point of view. Of course, this is the story, right? But I'm telling you, there are costs of keeping these two things together. My main point is that with KF, with an external theory like KF, like a closed-off option, you already have a cost, right? And we've seen this cost. And is that so much worse? No, it has some advantages because it realizes this generalizing function better. You have these blind reasoning available, and I'm not sure if it's so much worse. Thank you.